Hey guys, welcome back. In this lecture, we will learn about analysis of continuous beam with mixed loading. Mixed loading means in a single continuous beam, we are learning to apply all the types of load like point load, uniformly distributed load, and uniformly varying load in a single continuous beam. Till now, in previous lectures, we learned how to apply a load in a single beam, but a same type of load we applied. In this lecture, we apply a different types of load in a single beam. Okay, so let's begin. Go to the new project, plane, file name as beam or continuous beam. Length unit is meter and force unit is kilonewton. Next and finish. Front view. Look at the problem. There is one continuous beam. In continuous beam there is three beams. First is the 3 meter length, 3.5 and 4.5. Okay, so first we have to create a beam. Click on 0 and close the grid. Take a node cursor, select node and copy it and paste it. In x direction how much? 3 meter. Okay, then select second node, copy and paste. In x direction 3.5. Copy and paste. In x direction 4.5. Add beam and add all the nodes one by one. Go to general, property, define rectangle, YD is 0.3 and ZD is 0.2 meter. Add and close. To apply a same property in all the beams, just select all the beams. Go to assign to selected beams, assign and yes. Then go to support, create. What are the supports? Pin support, roller support, roller support and roller support. So we have to create one pin support and one roller support. Add, select the support. To highlight node, just press shift plus K. What is the first one? It's a pin support. Then roller support, roller and roller. So assign the pin support in first one and roller support in another nodes. Just go to load and definition, load case detail, add and make a title as load, as general load. Okay, because in a single title we have to apply all types of load. Click on load, add. Look at this, first one is a point load applied on center of the beam, right, of 4 kilonewton. Go to the member load and concentrated force and provide a value as -4, and no need to provide D1 and D2, okay, because the load is applied on center of that beam. Add this one, Then the second load is 10 kilonewton per meter of UDL in a second beam, which is in full length of the beam. Okay. So go to the uniform force, provide W1 as minus 10, and no need to provide D1, D2, D3 because load is applied on full length of the beam. Okay. Just add this one. The third one is a uniformly varying load or linearly varying load. W1 is 17 kilonewton per meter and W2 is 8 kilonewton per meter. This is also applied on full length of the beam. So we have to apply this load from linearly varying load. Go to linear varying and provide W1 as minus 17 and W2 is minus 8. Add this one, close, and assign all the loads one by one in the particular beams. Use cursor to assign. It's the best method. Okay, point load is applied. Select the UDL and click on second beam. Select the third load and click on third beam. Okay, just press Shift plus V to see intensity. The point load is of very long height. So go to scale and change the scale of point load as around 10. Okay, it's the 4 kilonewton load which is applied on center of the beam. Alright, go to analyze print, add and close, analyze and run analysis. Go to post processing mode and done. The analysis part is done. Hold control and scroll your mouse in front side. For bending moment, just go to the MZ. For shear force, just go to FY. Okay. Reaction. The table of axial force, maximum bending moment, and maximum shear force. Animation, section displacement, and OK. Alright, go to modeling. Look at the second beam. There is also different types of load applied on a continuous beam. So open new project. As a plane, length unit is meter and force unit is kilonewton. Go to next and finish. Click on 0. Take a node cursor, select the node, copy and paste. In X direction 2.3 meter. X direction 2.3 meter. Okay. Select the second node, copy this one and paste it in X direction 3.7 meter. 3.7. Select the node, copy it and paste it. In X direction 4.2 meter. 4.2. Okay. Then add beam one by one. Beam is created. Then go to general, property, define, rectangle, wide is 0.3 meter, and Z is 0.2 meter. Add and close. I'm using assign to view method. Just go to assign to view, assign, and yes, to assign a same property in entire structure. Then add beam one by one. Take a add beam, go to general property and define, create a new property, go to rectangle, YD is 0.3 meter and ZD is 0.2 meter. Okay, add and close. To assign this property in all the beams, just I'm using assign to view method, assign, and yes, with the help of assign to view, we can apply a property in all the beams. Go to support, create. What are the supports? All are pin support, right? Pin and add. Select the support and assign to view because all supports are same. Okay. Then go to load and definition, load case detail, add. Load title is provide just load, add and close. Select the title, add, go to member load. What are the loads? First one is uniformly distributed load. So go to uniform force. The intensity is 10 kilonewton per meter. Provide W1 as minus 10. Add. Then for second load, we have to choose the trapezoidal load. W1 is 4 kilonewton per meter and W2 is 6 kilonewton per meter. And what is the value of D1? D1 is 1 meter. Okay. And D2 is 3.7 meter. Go to trapezoidal, W1 4 to 6, W1 is 4, W2 is 6, D1 is 1 and D2 is 3.7. Add and close. Okay, do not close it. We have some more loads. Third one is a point load. Just go to concentrated force and provide a value as 14 kilonewton minus 14. What is D1? D1 is 1.5 meter. Okay, and no need to provide D2. 1.5. Add. The next load is uniformly distributed load or uniform force of 8 kilonewton. Go to uniform force, provide minus 8, and the D1 and D2. D1 is 2 meter and D2 is length of your beam as 4.2 meter. So D1 2 and D2 is 4.2. Add and close. Assign all the loads one by one. I'm using method use cursor to assign. Click on assign and then click on your beam. Select the second load, click on the beam. Third one, click on the third beam. Then we applied all the loads. Just go to scale and change up scale of point force as 10. Okay. Shift V to show intensity. Alright. Then go to analyze print, add and close, analyze and run analysis. Save. There are 3 errors. What are the errors? elastic modulus is not entered. So just go and check whether the material is applied or not. There is a material of concrete, but sometimes software is not taking the material, so we have to save this file. Close the file and reopen it from StatPro. It is present in recent files. Take a front view and go to General, Property, and look at this. There is no material. Okay, so just double click on this material or go to Edit. Select any other material like steel, aluminum, change it, and again edit this one as a concrete. Okay, it's a concrete. Now analyze and run analysis. So you have to also learn how to correct the errors, because in analysis lots of time you will have that type of error. Okay, just write it down, because in analysis software sometimes miss some data like material size or support. So just close the program and reopen it and change the property. Okay, go to post processing mode and done. Okay, hold your control button and scroll your mouse in front side. Go to reaction to show reaction. Go to animation and section displacement for animation. Alright, look at the third problem. It's your task, just do it. First one is a point load applied on center of the beam, so no need to provide D1 and D2. Second one is a point movement, which is also applied on a center of that beam. So no need to provide D1 and D2, but this load is in clockwise direction. So you need to provide this load as minus sign or -4. The value is -4, okay, in point movement. The third one is the uniformly varying load or trapezoidal load. We have to apply this load on trapezoidal load, okay. W1 is -13 and W2 is 18. Now what is the value of D1? D1 is 1 meter and D2 is the difference in between 2.5, right? So D2 is 3.5. What is the value of D2? 3.5. Okay, just do it. Thanks for watching this.